This Asiana Airlines Boeing 747 was en route to Shanghai. Unbeknown to the crew, a fire had broke out in the cargo bay and within minutes had grown to engulf the aircraft. What you're about to see is what happened to this flight and how it was able to occur. To see what happens next, stay tuned. On the 28th of July 2011, about 0411 Korean Standard Time, Asiana Airlines Flight 991, a Boeing 747-400, was scheduled for a cargo flight from Incheon, Republic of Korea, to Shanghai in China. The captain and the first officer showed up at the flight crew ready room at Asiana Airlines in Incheon International Airport, about an hour before the scheduled time of departure. They signed the show-up log, and then the flight crew arrived at the aircraft and the captain performed the ramp inspection. The loadmaster stated that about 0215, under the guidance with him, the captain inspected the loaded status of dangerous goods and other shipments in the main cargo compartment. Once the captain and the loadmaster were happy, the captain joined the first officer in the cockpit. There was a very experienced crew on board this flight. The captain was 52 years old and was hired by Asiana Airlines on the 2nd of July 1991. After working as a Boeing 737 and 747 first officer, he was promoted to a Boeing 737 captain on the 24th of December 1996 and a 747-400 captain on the 3rd of July 2001. He had accumulated 14,123 total flying hours, including 2,501 hours as a Republic of Korea Air Force pilot. He flew 6,896 hours in the Boeing 747, including 5,666 hours as a pilot in command. The first officer was 43 years old and he was hired by Asiana Airlines on the 2nd of April 2007. He was promoted to a Boeing 767 first officer on the 5th of February 2008 and Boeing 747 first officer on the 4th of November 2010. He had accumulated 5,211 total flying hours and was also previously in the Republic of Korea Air Force, where he accumulated 3,010 hours. Since he was hired by Asiana Airlines, he had flown 1,709 hours in the 767 as a second in command and 492 hours in the 747 as a second in command. For the aircraft itself, it was manufactured by Boeing on the 15th of February 2006. On the 22nd of February 2006, it was delivered to Asiana Airlines and registered under the Korean Airworthiness Authority. The aircraft held an airworthiness certificate issued on the 24th of February 2006, and it had accumulated 28,752 total flying hours and 4,799 total cycles. The crew were satisfied with the maintenance record of the aircraft and the flight plan and weather. Before starting their engines, they got an update on the weather for the departure airfield, and it showed that the wind was coming from 200 degrees at 20 knots, visibility was 10 kilometers, it was overcast at 8,000 feet, the temperature was 26 degrees Celsius, and the pressure was 1007 hectopascals, with a slight possibility of light rain. The crew now requested clearance to Shanghai, and they were cleared by the tower, departing from runway 15 left on the Malpa 1 Romeo departure. They then requested pushback and prepared for their departure whilst on the taxi to runway 15 left. As they approached their taxi holding point, air traffic control asked them if they were ready for departure, to which they replied they were. At 0301, they wwere cleared for takeoff. The crew lined up the aircraft on the runway and pushed the thrust levers forward to accelerate the aircraft down the runway. At 0304, Flight 991 took off from runway 15 left. Shortly after takeoff, they made initial contact with Seoul Area Control Center and was instructed to climb to 34,000 feet and fly direct to Malpa. The crew continued as normal, settling into their flight to Shanghai. As they broke through the cloud, the skies were clear and the weather was looking calm for the duration of their flight. They swapped between air traffic control frequencies and just over 40 minutes later, at 0351, they were instructed to contact Shanghai Area Control Center on frequency 134.0. On their initial contact, they stated that they were maintaining 34,000 feet and flying direct to Sadly. Shortly after this, Flight 991 was instructed to offset 5 miles right of track for traffic avoidance. The flight crew carried out this instruction, and as this was a relatively short flight, started thinking about setting up for their approach and landing at Shanghai Airport. It was at this point that the crew got an indication that something was wrong. At 0352, they received an equipment cooling caution along with equipment smoke and cargo fire main deck zone 11. The equipment cooling message is a caution that informs the pilots of a problem with the electronic equipment compartment cooling system. One of the several ways this message is generated is when the equipment smoke message, which indicates smoke is detected within the electronic equipment compartment, is displayed for more than 3 seconds. Cargo fire main deck zone 11 indicates that smoke was detected in zone 11 of the main deck cargo compartment. The crew took a moment to diagnose the problem and prepare themselves with the correct checklists for the issue they were having. They were still 165 nautical miles from Shanghai at this point, but their nearest suitable diversion was Jeju Airport, which was 125 nautical miles away. The crew now had confirmation of their fears, with a fire main deck aft warning appearing in front of them. The first officer now spoke with air traffic control and stated, Shanghai Control, Alpha Alpha Romeo 991, request emergency descent, declare emergency due to fire main deck, request descent and descent to 10,000. Shanghai Control acknowledged the message and gave Flight 991 a descent clearance and instructed it to turn at its own discretion. The first officer now requested that they divert to Jeju Airport by saying, we have fire main deck, Alpha Alpha Romeo 991, return to Jeju. Shanghai confirmed this request and a few minutes later instructed Flight 991 to maintain 10,000 feet. However, they didn't receive a response. They then started to get broken information from them, and both parties were struggling to understand each other. Shanghai Control then requested a nearby aircraft, Korean Airlines Flight 886, to contact Asiana Flight 991 and, if possible, relay any information from them back to air traffic control. The Korean Airlines flight then confirmed that the struggling Asiana flight was descending to 10,000 feet and flying direct to Jeju Airport. The situation was only getting worse for the crew of Flight 991, as they now received several more messages informing them that there was a cargo fire in main deck zone 10, 6, 7, 3, 8, 4, 5 and 16. After the initial delay, the crew were in the middle of carrying out the Quick Reference Handbook Fire Main Deck checklist. Their oxygen masks were on, and they had armed the main deck's cargo fire arm switch. The purpose of this action is to get 2 of the 3 air conditioning packs to shut down, causing the airflow to the cargo compartments to be shut off. This is the main fire suppression system for the main deck. The aircraft is equipped with 3 air conditioning packs, and these are used to cool and draw hot air away from areas of the aircraft. When there is a fire in the forward equipment racks during flight, or a pilot puts the equipment cooling control switch into the override position, 2 fans for cooling forward equipment racks stop their operation, and the smoke override valve is open, thereby exhausting air in the racks overboard. When the main deck arm switch is pressed, 2 of the 3 air conditioning packs shut down and airflow to the cargo compartments is shut off. 1 pack continues to operate to provide fresh air to the flight deck and supernumerary area to prevent smoke from entering occupied areas. This essentially starves the fire of any oxygen, preventing any further combustion. When the crew carried out this action, the air conditioning packs worked as they were supposed to, and the airflow was restricted to the main deck. The issue with this fire was that this was burning extremely hot and using its own fuel source. We'll have more on this in a moment. As the crew were continuing with their checklist, one of the main parts of the fire main deck actions was to remain at 25,000 feet for as long as possible whilst en route to the nearest suitable airport. The reason for this was based on studies by the National Fire Protection Association, the FAA, and other literature available. The data indicates that approximately 4 times the ignition energy is required to rekindle a fire at 25,000 feet in comparison to that of 5,000 feet. This meant that in theory, 25,000 feet was the optimum firefighting altitude due to the natural suppression of the fire and the tolerance of the flight crew when it came to decompression sickness, hypoxia, and terrain clearance. The fire in the main cargo deck was continuing to grow. The crew were working hard to try and get things under control. They had carried out all the actions for a fire in the main deck, declared an emergency, and were on their way towards their diversion airfield. Even with the core elements under control, the aircraft was continuing to inform the crew of multiple issues. The autopilot disconnected, along with the yaw damper, and from this point they were bombarded with more and more problems. They were receiving cautions for the APU fire loop, bottle low APU, the ELT on, EIU disagree, battery discharge APU, and several more. The wire running at both the upper section near the scene of the fire or under the main deck cargo floor was likely short or open circuit due to the fire. Messages associated with the system faults are generated by the signals sent through the wire, and when the wire is damaged, it's likely to send faulty signals, thereby generating messages. Thus, many of the messages transmitted via this system cannot be seen as necessarily consistent with the actual situations. For example, the message ELT on is generated when the pilots turn on the ELT, and that stands for Emergency Location Transmitter. Although Flight 991 flew for more than 10 minutes after the message was generated, however, its distress signal was not received by the ground stations. In addition, messages Det APU fire, battery discharge APU, and APU are generated when there is a fault with the fire detector, battery discharge, and fault with the ducts respectively. The APU is irrelevant to the main deck cargo fire due to the APU firewall, and the fire had not reached this area. Even though some of these messages were likely false, the main issue still existed, and these cautions and messages were only adding to the stress and pressure in the cockpit. At the same time, they were having issues with their radios. Shanghai Control instructed Flight 991 to contact Ichon on 124.52 for a Jeju approach. The first officer tuned the radio and attempted to make contact, but nothing was heard. He then returned to Shanghai Control, and they were given further frequencies to try, and all of which were silent. Shanghai Control got in touch with Korean Airlines Flight 886 again, and informed them that they will need to relay information from Flight 991. They set their transponder to 7700, which is the emergency squawk, and the fire was beginning to swell and engulf much of the rear of the cabin. As they continued in their descent, they were losing rudder authority and control of the aircraft was becoming more irregular. Korean Airlines 886 got in touch with Ichon Control and relayed a message to Flight 991. They stated, "Relay from Ichon Control. Maintain heading 060, radar vector for final, and you may descend to 7,000 feet. The captain responded with descend 7,000 feet. Both crew members were frantically trying to get the aircraft under control. The first officer was ensuring all checklists were carried out, whilst the captain was wrestling with the controls to maintain control of the aircraft. Meanwhile, the fire was starting to consume the aircraft. Shortly after, he then contacted Korean Airlines 886 and reported, "We are now that rudder control is not working and seems to be fired." They were struggling to maintain their heading. The aircraft was weaving, turning right and left, never maintaining 060 degrees, but fluctuating almost 40 degrees either side of that. They were experiencing heavy turbulence caused by the fire's rapid propagation and damage to the aircraft control cables and electronics. The aircraft was beginning to become unstable in pitch, roll, and yaw. The fire was now causing parts of the aircraft to break apart. The crew were continuing to transmit on the radio and stated, "Rudder control, flight control are all not working." They then received contact with Jeju Approach Control. They stated, "Alpha Alpha Romeo 991, yes, I can hear you." The crew now had no options. The aircraft was now almost completely uncontrollable, and the fire had spread throughout the entire cabin, and the structural integrity of the aircraft was becoming an issue. The first officer of Asiana Flight 991 informed Air Traffic Control that we have heavy vibration on the aircraft. We may need to make an emergency landing, emergency ditching. The controller responded, "Yes, say again please." At this point, the aircraft started to rapidly descend towards the sea from 9,000 feet. In this uncontrolled dive, the first officer transmitted, "Altitude control is not available due to heavy vibration. Go into ditch." This was their final transmission. The aircraft continued to rapidly descend before impacting the sea 71 nautical miles west of Jeju Airport at 04:11 hours. And the aircraft was completely destroyed and both pilots lost their lives. When they came to investigate how this could have happened, they looked at both the actions of the crew and the cause and result of the fire. Identifying the cause of the fire proved difficult. They first looked at the initial outbreak of the smoke and fire from the cautions shown to the crew, and this was determined to be within Zone 11. When they checked the cargo within this area, it was shown that lithium-ion batteries, photoresistant LCD resin, paint, and seal lacquer were present in the dangerous goods cargo. For the photoresistant LCD liquid, it is a highly flammable liquid with a flash point of 43 degrees Celsius, and the flash point being the temperature in which the product can vaporize to a form of an ignitable mixture in the air. The paint, again highly flammable, had a flash point of -1 degrees, with the lacquer having a flash point of 43 degrees Celsius. All of these products were sealed and stored correctly. Now for the lithium-ion batteries, the board examined a sample of the battery that had been loaded on the accident airplane and packaging materials, but failed to acquire the data that could prove the ignition possibility of the batteries in normal conditions of transport. At the same time, there was a history of similar incidents where lithium-based batteries were involved. There was an in-flight fire on UPS Airlines Flight 1307, which occurred on the 7th of February 2006. 36 other serious incidents involving batteries and battery-operated devices had been reported. Among them, 23 serious incidents related to lithium-ion batteries or lithium metal batteries. On the 3rd of September 2010, UPS Airlines Flight 6, a Boeing 747-400 with lithium-ion batteries on board, developed an in-flight fire. The first of the 8 causes of this accident were that a large fire developed in palletized cargo on the main deck consisting of mixed cargo, including a significant number of lithium-type batteries and other combustible materials. The fire escalated rapidly into a catastrophic uncontained fire. For the battery itself, it was determined that if a lithium-ion battery was exposed to excessive heat due to a fire, the battery had the potential to release flammable vapors. Also, if exposed to an external short circuit, crushes, modifications, or temperatures above 100 degrees Celsius, the battery could release heat and self-ignite. The lithium cell undergoes a chemical reaction once it is heated to the point of thermal runaway. This chemical reaction generates a very high temperature and pressures within the cell. A cell in thermal runaway can reach 593 degrees Celsius or 1100 degrees Fahrenheit. This temperature is very close to the melting point of aircraft aluminium. A large shipment of lithium cells could generate enough heat to potentially damage the structure of an aircraft like we saw in this incident. The focus now fell on how it was ignited. It was quickly determined that there wasn't a damaged wire that could have emitted a spark. They then looked to a charge caused by electrostatic energy, which could have been generated by the plastic wrap used to bundle the pallets together. It was shown that it was extremely unlikely, but possible. Further reinforcing this suggestion was that the paint that had a flash point of -1 degrees was stored for 6 hours at 26 degrees prior to the flight. It could have been that this produced enough vapor to ignite the cargo later on, but it could not be confirmed. During the investigation, it was tested that once the cabin altitude was at 8,000 feet, which is when the fire started, there was no volatile organic compounds detected. The ignition source for the fire could not be confirmed. It could have been that the storage system of some of the dangerous goods failed, such as the lids of the paint, or, as we've seen before, it could be that a defective battery caught fire and it carried on from there. The definite source could not be determined. The investigation now looks at the actions of the crew and if anything could have been done differently to create a different outcome. As we discussed before, it was written in the Quick Reference Handbook, the optimum altitude for airborne firefighting was 25,000 feet. The crew, on the realization of the fire, requested a descent straight to 10,000 feet. It is possible that the flight crew intentionally did not stay at 25,000 feet because they may have regarded the situation as serious and needed to make a ditch-in. There was also a discrepancy with the checklist, which did not include the need to remain at 25,000 feet. It was determined that even if Flight 991 had maintained 25,000 feet, the fire would have not been extinguished by the top of drop point at Jeju Airport. And that, in this case, as the oxygen levels increased during the descent, the resulting fire would lead to the same outcome and the result of this accident would have not changed. As we just discussed, there was an additional issue of which checklist was used. Asiana Airlines had 4 kinds of Boeing 747 aircraft, the passenger variant, combined, freighter and SF, and their non-normal procedures were specified in one Quick Reference Handbook. This might have caused a flight crew to delay or make a mistake while selecting applicable procedures in the Quick Reference Handbook. When referring to the freighter's fire main deck non-normal procedures in the Boeing 747, there is a possibility that the flight crew selected the combi plane's procedures, which were filed right before the freighter's procedures. The basis for this assumption is that the checklists differ, and based on the timeline and actions by the crew, it indicated that they may have been using the different checklist. First, the combi plane's fire main deck non-normal procedures do not contain the 25,000 feet requirement. Second, the freighter's fire main deck depressurization procedure was delayed. This refers to when the crew armed the main deck firearm switch. It was delayed for about 2 minutes. Step number 1 of the combi plane's procedure is to instruct the designated crew member to verify the presence of smoke or fire. If the captain personally verified the presence of fire, it would explain the 2-minute delay to carrying out this action. In addition to this, the flight crew failed to turn on the supernumerary oxygen switch, which is specified in non-normal procedures in a freighter's fire main deck checklist, but not in the combi planes. The switch was found to have the wire still attached after the crash, with the switch in the normal position. If the flight crew had implemented the freighter's fire main deck non-normal procedures in a specified order, the supernumerary oxygen on message should have been generated earlier than the pack 2 and 3 messages, but it was generated 3 minutes after them. One final point is that Asiana Airlines didn't have a specific cargo variant for their simulator training. The training crews would use a passenger variant and simulate the cargo elements, such as fire on the main deck. As a result of this incident, the following safety recommendations were issued. For Asiana Airlines, it was to ensure that flammable liquid, dangerous goods, and lithium batteries, which were bearing the cargo aircraft only label, are segregated and loaded on separate unit load devices. They were also informed to load lithium batteries classified as dangerous goods into Class C cargo compartments. This would allow for a built-in fire extinguisher or suppression system controlled by the cockpit. In this instance, only the lower cargo compartment of Flight 991 was a Class C compartment, with the main deck being an E-class cargo compartment, which means that it only had the requirement to shut off the ventilating airflow to or within the compartment. They needed to produce and equip their aircraft with a Quick Reference Handbook that contains only the procedures required for the operation of that specifically configured aircraft. They needed to operate their simulators in such a way that the flight crew can realistically train on non-normal procedures of a passenger, cargo, or combi plane. There were very similar safety recommendations issued to the Office of Civil Aviation and Boeing, looking at the storage of dangerous goods and the implementation of fire extinguishing fittings. The full list is within the final report linked in the description. And that's all we have for today. I really hope you're continuing to enjoy the videos and are finding them interesting. And I really hope you're having a great day. And as always, I'll see you in the next one.